Hi, Yasmina. And hi, everyone. Thank you for joining this webcast. And as most of you probably already know, eye tracking is a process of identifying where someone is looking and how. And typically it's done with the help of a device called an eye tracker. A few eye trackers are shown here on this slide. Eye tracking can be done for various reasons. You can control interfaces with your gaze. For example, you can play a video game, or you can type by using just your eyes. But when I talk about eye tracking, I talk about using it for evaluating the user experience of interfaces. And that's what the book that Yasmina mentioned is about, and that's what this webcast is about. And now, when I say user experience, I mean it in a very broad sense. And as you would probably agree, it is just so much more than just usability and so much more than just about websites. The examples in this presentation and as well as in the book come from a variety of studies, from websites to physical products and even physical environments. And now I'm going to be honest with you. I am not doing this webcast because I love eye tracking. I didn't write the book because I wanted to sell everyone on eye tracking. I was actually a little bit displeased and a little disappointed. And not necessarily with eye tracking itself, but with what was and still is happening to it in our field. When I started using eye tracking, and that was almost 15 years ago, most eye tracking research was happening in academic settings, and that's also where I started. But in the last decade, as you all probably realize already, eye trackers have become easier to use, less expensive, and overall just more accessible to practitioners, including UX practitioners. And a lot of them use eye tracking these days. In many cases, you can probably even teach a child to calibrate a participant and track that participant and produce a heat map. It is that simple, for better or worse. And as a result, what we've seen is over-reliance on data visualizations and not much actual data analysis. The heat map basically became the face of eye tracking at some point in that last decade. And it's understandable. At first, many people were excited about the interesting information that eye tracking could show us. We as practitioners were finally able to see what we couldn't see otherwise with the naked eye. We could finally see how users were distributing attention when interacting with our interfaces, and that was very interesting. But while that information was interesting, as practitioners, we obviously don't conduct research to learn interesting things. We conduct research to make decisions, either design decisions or business decisions, but there's always some decisions that have to happen at the end of the research. And a heat map won't magically tell you how good a design is or what to fix in a design. So what we have here is the so what problem. The so what problem is not necessarily specific to eye tracking, but because eye tracking produces such engaging output, we often forget that the findings also have to be actionable. And I noticed over the last couple of years, a lot of research stakeholders have gotten smarter. They ask better questions, and they no longer are entertained by eye tracking just for the sake of eye tracking. They no longer want to see pretty heat maps. And I think it is safe to say that at this point, the eye tracking hype is over, at least in the UX research field. As some of you are probably aware that some have even compared eye tracking to certain non-scientific practices, and they have concluded, based on the research that that is available on the web, that eye tracking is just simply not useful. I really can't blame them. Unfortunately, there's a lot of overly simplistic or incorrect information about eye tracking out there. A couple of years ago, my colleague Kristen Adamczyk and I described the main misconceptions about eye tracking in an article that was published in the UX magazine. If you want to access it, the URL is listed in the top right corner. And what we did in this article is we just listed the 10 misconceptions, and here are the 10 misconceptions that we wrote about. We're not going to necessarily discuss them all today, but they range anywhere from, eye tracking is all about heat maps to you need 30 participants for an eye tracking study. So these are those kinds of things that we talked about in that article. And this article happened to be the precursor to the book. It mostly focused on explaining what not to do. And however, the book was supposed to be a how-to book. So suddenly I had to shift my focus from what not to do and I had to write about what to do. And that was actually a little different and a little bit more challenging. Now the title of the book is Eye Tracking User Experience. And even though the title might suggest that the book is about eye tracking only, it's really more about using eye tracking properly and in conjunction with other UX research methods. So I'm certainly not advocating that eye tracking is all you need to evaluate the user experience. And about a quarter of the book is about when eye tracking could be helpful in UX research and why do it. And the rest is really about how to properly prepare and execute an eye tracking study, how to analyze the eye tracking data in the context of other findings. So today, this webcast really will focus mostly on the why and when, or in other words, how to decide if your research study would benefit from the addition of eye tracking. To make that decision, I use something that I call the to track or not to track decision tree. And this tree has actually evolved over the years. It used to be a lot more complicated, but now it only consists of 3 questions. And these are yes or no questions. Based on your answers to these questions, you get to one of the 2 outcomes. One is okay to track, and the other one is stop, no need for eye tracking. The first and most important question is, will eye tracking generate actionable insight that addresses my study objectives? And if you're having trouble seeing all the words, I'm pretty sure that the slide area can be maximized on your interface, so you can see it a little bit better. So the first question is, will I be able to make a decision based on what I learned from eye tracking? Now, if the answer is no, you don't do it. There's no other questions that you need to ask yourself. Because if you do it, you will run into the so what problem. Now, this question, will eye tracking generate actionable insight? This question should not be mistaken, and it often is, for will eye tracking tell me something I don't know, or will it tell me something interesting? This is when we get to decide what's just interesting and what's also useful. Now, this is one of my pet peeves. I want to know where users are looking is not an appropriate objective for a study. I've heard it many, many times, and every time I hear it, I ask my stakeholders, okay, why would you like to know this? Or what decisions are you hoping to make based on the study findings? Now, when deciding whether eye tracking is useful for a study or not, the starting point is usually, is this a formative study or is this summative research? So are we looking more for qualitative insight, or are we focusing on the quantitative insight? And let's talk about the qualitative side first. Now, in a typical usability study, you're able to observe participants' actions. So you will see when they're clicking, when they're scrolling, and you're going to end up with some gaps in information. Something is obviously happening between those clicks, between when they're typing or doing something else. You might be able to see their face, but still there's some gaps. And if there is think aloud protocol involved in the study, the participant obviously will be verbalizing his thought process, but the quality and amount of these verbalizations really depend on the participant. And some people are really great at this, and a lot of people are not. And still, it's just impossible to think aloud during the entire process. And usually when the most important or the most interesting stuff is happening, people are focusing on what they're doing. Perhaps they're confused. They're not really thinking aloud at that point. Now, in most eye-tracking studies, the moderator and observers can take advantage of live viewing. And basically, this means that they can see the participant's gaze location in real time. So the picture on the left is the participant actually sitting in front of an eye tracker, and the picture on the right is the moderator of the study looking at what the participant is doing at the monitor. And also, if you see the red dot, that indicates the focus of the participant's attention. And this way, you simply get a more continuous stream of information. And now this information can be used in a couple of different ways. First, it can help the moderator. It basically makes the moderator a little smarter. It can help the moderator ask more informed questions during the study, or she can ask questions at a better time during the session. And I think that the latter one is a very important point. For example, the moderator can probe on elements of interest to the study after the participant has discovered them on his own. Perhaps he hasn't used that element that's of interest to the study, but the moderator knows, okay, the participant has looked at it, now I can probe about it, instead of probing about it and not letting the participant discover those elements first. And the second way we can use this information is after the study. Gaze plots, gaze videos, they can also be analyzed qualitatively after the study. Now, this additional layer of information that we're getting about the participant's focus of attention can be used to detect and explain usability issues. So now we're adding detecting usability problems and explaining usability problems to this chart. And we're going to build this chart throughout this webcast. Now, this is where the actionable part comes into play, because a good understanding of usability issues, especially their sources, so what caused them, leads to more specific or better design recommendations. Now let's talk about one side of this, which is detecting usability problems. Eye tracking is sometimes able to detect problems when conventional usability testing methods don't necessarily indicate that there is a problem. Here's an example. The task here was to find Baby Dream bio formula for a 4-month-old baby. The participant, an expectant mother, selected the correct product. And here's her scan path. In a scan path here, the circles indicate fixations, so where the eye paused briefly to extract information. And the larger the circle, the longer the fixation. And the numbers in the circles, you may not be able to see them, indicate the order of the fixations. Now the participant here, what I circled as the target is the correct product for that particular task. The participant briefly looked at it at first. Then she went toward the blue package all the way to the right. And that blue package has a large number 4 on it. Now, eventually, she realized that the blue box contained milk for children 12 months and older. So she went back to the yellow box, which is the correct box. Now, this happened pretty quickly, and her selection was correct. So the outcome of the task was correct, and she did not report any problems. But her scan path indicates that there is a potential confusion here. There's a potential problem associated with numbers. Now here's another example. This is an annual renewal notice on the back of a credit card statement. This participant was able to correctly answer all the comprehension questions that we gave him, but his fixation density, as you can see here, increased in the middle of this text on this particular page. and that indicates potential comprehension difficulties. On average, when reading, we make fixations every 7 to 9 characters. We don't look at every single word. A lot of times we skip the shorter words because we can just see them. We don't have to necessarily fixate on them. But with more complicated text, the fixations will be closer together. They will also be longer, so the circle suddenly will become a little bigger. And you will also see more regression. And that's when the eyes basically go back to reread what you already read. On average, we make about 10 to 20% of 10 to 20% of our saccades go backwards on average. So if there's more of that happening in the text, we know that the text is difficult. Now, unfortunately, this type of insight is not that common. And I'm sad to say that, but it's not that common for eye tracking to reveal something that we completely did not see during the study. And the reason for that is, if there really is confusion, someone in your study eventually will make a mistake or say they were confused, and the higher your sample size is, the more likely this is to happen. Or in iterative testing, you're finally going to find something with the sort of conventional usability testing methods. But if all you can do is one small usability test, and let's say your timeline is very limited, I would say that qualitative analysis of eye tracking data may expose participant difficulties that perhaps were not obvious otherwise. Now, more often, eye tracking findings can be used to explain the sources of issues that we already discovered in other ways. So let's look at some examples. Now here's some questions, and by looking at eye tracking data, we can figure out the answers to these questions. So we can figure out why users clicked on an incorrect link, why something took a little bit longer, a lot longer than expected, why users didn't extract the information that they were supposed to extract from the interface. These questions can come up either prior to the study based on known problems and other methods that you've already used, but they can also come up during or after data collection as a result of problems observed during that particular study. Now, this image is from a study on prepaid mobile phone packaging. And here participants were given a series of questions about the capabilities of the phone in the tested package. One of the questions here was, can you go on the web with this phone? Now, several participants who looked at this particular package said that the phone didn't have that capability. Now, the target of this particular task or search was the word browsing, listed right here where I circled it on the slide, and it's listed right there together with all the other features. So when something like this happens, people said, no, you can't go on the web, but you obviously can. The question always is, did they not see it? Did they not understand it in the context of the task? What happened here? Now, this is a sample gaze plot from this particular task. As you can see that this participant did locate the list of features on the left and did look at the word browsing. But obviously, he did not recognize it as relevant to the task. So this is what I call the target in disguise problem. Now, in this study, our main goal actually was benchmarking using several different phones. Accuracy and time on task were automatically scored, and we didn't really have any other way to get to the why once a problem was identified. So in this case, having the eye tracking data was quite useful. And here's another example. The task here is to pick a paint color for your house or a room in your house and get a small sample jar of that paint that you chose. The participant in this example wanted a Premium Plus Ultra color, so she clicked on the left side of the screen. Now on the next screen, she then selected a color swatch on the left out of all those little swatches. Then a large color swatch, that same color appeared on the right. Then she clicked on it. And then she got a little pop-up. She selected the button where it says Buy Sample. And now this pop-up screen appeared. And she immediately selected, on this screen, she immediately selected the Add to Cart button in the bottom right corner. And since the pop-up didn't disappear, then she clicked on the Close button in the upper right corner. But then when she went to her cart at the end of the task, she realized that her sample just wasn't there. So she did not complete the task successfully. Now, so what happened here? Looking at the participants' fixations, she confirmed the color and then went straight to the Add to Cart button. She didn't even look for any other controls. And when the pop-up didn't disappear, she showed absolutely no confusion. And you can see here that she wasn't looking for any cues. She didn't even realize that there might have been an error, and she completely missed the error message that I circled here on this screen. So we had a target in disguise in the previous example, but here we have a couple of hidden targets, things that people just don't see. This is Wikipedia's homepage, and this participant in this particular task was asked to donate money to Wikipedia. And you can see here from his scan path, he looked at in a lot of places, but he didn't click on the correct link. And the donate link was on the left, and it's circled, and there is an arrow pointing to it. Now, from the scan path, we can identify the areas where he expected the option to be located. We can see that the left navigation wasn't even strongly considered in this search. And it's not that he looked at the link and didn't understand it. It's not that he looked through all the options on the left and just somehow missed it. This is the kind of information that we can turn into a good recommendation. Here we'd be suggesting that the link be relocated rather than renamed, for example, and we already have some ideas where participants might expect something like that, based on obviously not just this participant, but other participants as well. So we just talked about qualitative insight, and now we're going to look at the types of quantitative insight that eye tracking can provide. Now, quantitative insight is more useful in summative studies, but not just any summative studies. And let me show you what I mean by that. How large is this animal? If you've never seen it, you don't quite know. You can't tell. But here, when you see it next to a child, you realize how small it is. This is actually the smallest primate. The point I'm trying to make here is that quantitative eye tracking research is all about comparisons. This is really not just relevant to eye tracking, as you can imagine. A number on its own is just not useful. You have to compare it to something to give it a meaning. For example, if, let's say, participants made an average of 10 fixations to find something on a web page, if that happens, I have absolutely no idea if that search was efficient or not. I don't know. And that's not very actionable, because there are no general eye tracking benchmarks, so I have nothing to compare it to. We would have to, in this case, we would have to have something to compare it to. Or if we wanted to find out how much attention a billboard attracts, we would, again, have to compare it to something, either other billboards in the same area or different versions of the same one. We would have to have something to compare it to. And how are these comparisons actionable? Well, they inform decisions, such as which design version should be selected, or if the product is, for example, ready for launch. And here, our chart is finally complete. We can, on the quantitative insight side, you can see that we can measure, we can use eye tracking to measure performance-related differences, so where it says measuring performance, or we can measure attraction. Or specifically, we can measure attraction-related differences. So again, I'm stressing the comparison point. Now, let's look at some examples of studies that could use eye tracking to measure performance. And we're going to get into more details in just a minute. But here are just some examples. Here, for example, call center applications. And here's a sample research question. Will the redesigned layout make information easier to find and compare? For example, in one of the studies on a call center application that we did a while ago, we counted the number of gaze transitions between areas of the screen. And if the information is not laid out well, there's going to be a lot of looking back and forth and overall just long travel paths. You always want to make sure, obviously, that the redesigned layout is more efficient. Or think of pharmacists. They have to grab the correct medication from the shelf or a drawer to fill your prescription, and we really don't want them to be making errors and give us the wrong medication, obviously. So when a new label is designed, a new drug label, we want to know if it will be easy to distinguish from the existing labels. And eye tracking, there are certain measures that can certainly help determine this. Now here's an example about mental workload. And the sample question is, how does our GPS affect drivers' mental workload as compared to the competitors? If that's your study question, eye tracking can also provide data to answer this question. And the last example here about performance is about the ease of information processing. Let's say we're studying patient inserts or other types of instructions. Eye tracking can help us compare them in terms of how easy they are to read and understand. And here are some examples of attraction-related research questions that eye tracking can answer. For example, which page location will make our ad most visible? Or which ad design will create most interest? If there are a few versions, then we may want to know which one is best, which one we should go with. Here's another question that eye tracking can help answer. Which shelf location is best for our product to be noticed? And this is not just for ads or packaging. It applies to websites too. These attraction-related differences or questions are not strictly, as you realize, they're not strictly usability questions. But I know they're not unfamiliar to many of us, to many UX researchers. We all know that companies want more engagement in their promotional material and product themselves, and eye tracking is actually very well suited for this. But how do we measure all that? I just told you we can measure all these things, but how do we do that? Well, there are a lot of measures. There are actually more than 100 eye tracking measures. For example, and these measures include things like pupil diameter, average fixation duration, dwell time, number of fixations on an area of interest, or time to first fixation. There are many more of those. And different measures can mean different things in terms of cognitive processes. So it's important to match the right measure to the right cognitive process that you're trying to measure. Now, there's several different classifications of eye tracking measures. And this is probably the one that I came up with. It's not the most elegant, and I bet a lot of academics would roll their eyes, but it's very practical because it quickly helps you choose the appropriate measure for your study. And you don't need to read all this. We're going to go through a couple of examples. Now here are measures of performance. One of the examples that we're going to look at now is going to be about measures of cognitive processing. So the second item on the list, cognitive processing measures, and those measures include the average fixation duration. Now, think of reading prescription medication labels. In this particular study, the question was, this is a label for a prescription drug, and the question that the study question, or one of the questions, was if the additional languages on the label and the additional company logo would affect pharmacists in any way. And you can see in this particular example, we tested several different examples, but in this particular example, there are 3 languages used on the label, and we tested the logo. The question was about the larger company logo. And now, pharmacists don't make a lot of errors. That's actually a good thing, right? But especially when they're tested in the lab, they're not going to make an error. If we ask them to fill fake prescriptions, they're really going to pay attention. So error rate is not a good measure in this case. So we need to find things that we can measure in the lab to see if these users might be affected by the additional elements. In this case, what we decided to measure was the average fixation duration, to see if perhaps the labels with more text were a little bit harder to process than the labels with just one language, which was the language of the pharmacist. And these are our findings. Along the x-axis, we have the three different language conditions. We tested labels with 1 language, then 2 languages, and 3 languages. And along the y-axis, we have the average fixation duration in milliseconds, which was our primary measure in this case. And then we have the 2 different lines represent the 2 different conditions regarding to the logo. Some of these labels had the big logo, and they're represented with the blue line, and then the rest didn't have the logo, and those are represented with the orange line. And basically what we found here is we didn't find any differences, and that was a good finding for this particular study. Now let's look at measures of attraction. Here we have measures of noticeability, interest, and emotional arousal. And they are meaningful in this particular order because first you want your product to grab attention or be noticed. Then you want your product to maintain that attention or trigger interest. And then induce desire or positive emotion. And that's why usually these measures, at least 2 of them, are used together to sort of get the whole picture. This is a rather simple example, but I wanted to put it next to the other example about the average fixation duration, just because I want to show you that these measures don't have to be that complicated. And this is a measure of noticeability. The graph here shows the percentage of participants that looked at a poster. We had, in this case, 2 different versions of a poster for a particular product, for the same product. And one of our measures was percentage of participants who looked. And in this case, in this study, we had posters. One of the posters got 29% viewing rate versus 8% for the other poster, and that was statistically significant. And then that was actionable to the stakeholders, which direction they should take with their designs. So we're back to our tree and the 3 questions. So if the answer to the first question in the decision tree is yes, and you know that from looking at the circle, and a lot of times it is a yes, it can provide us with some actionable insight, There are studies, obviously, where eye tracking just might not be completely useful. Let's say when you're studying whether the utility of certain features that you're adding to an app. That obviously that would not be it would not be very useful to add eye tracking to that particular study. But if it's a yes, and you see that there is a good reason to use eye tracking, not just because it's interesting. Now the second question encourages us to reflect on the economy of that chosen approach. And the question is eye tracking the simplest method to answer our study questions? Now, why is this step necessary? Well, adding eye tracking to a study means, well, extra costs associated with eye tracking equipment, the software, training, additional time in the session, perhaps additional preparation time, analysis time. It all adds up. And we don't really want to overcomplicate things. Imagine a formative usability study, and all we want to do is we want to figure out if an app design is heading in the right direction. So not everything is fully finalized yet, as you can see. We grab a few potential users, give them a few tasks, determine the key issues, and then iterate the design. And then we test again. Now, adding eye tracking to a study like that might not be necessary. It's perhaps a nice to have, but not a must have. Now, if you already have the eye tracking equipment there, set up, you have researchers who are well trained in it, it probably does not add a lot of cost to the study. But if you were to get an eye tracker and get all the training just for studies like these, that might just be a nice to have. And that's because traditional usability testing methods are pretty robust. Behavior observation, verbal protocol, these are still things that are quite effective and less costly and less time consuming to conduct. And really a lot of usability issues can be uncovered those ways. This is something that I say sometimes, that a magnifying glass is often sufficient for what you want to see. You might not need a microscope. Eye tracking tends to be more useful later in the design process. And that's once the big problems have been solved, much of the visual treatment has been finalized. Then you might have specific questions that previous testing hasn't addressed yet. That's when I would say it's more useful. And sometimes eye tracking is the simplest or even the only method to answer your question. And there are always questions that are best answered by eye tracking. And these questions usually revolve around the attraction-related differences that we talked about a little bit earlier. In this example, one of the research questions was, this is meat packaging. One of the research questions here was where to place the recipe labels. And the labels contained recipes and suggestions for how to prepare the meat. So customers would have to first notice the label in order to take advantage of it, of that information. So we had to find out which location of that recipe label made the most sense and make the label most noticeable. And that was amongst some other research questions, of course. That was not the only question. So we have here a couple of conditions with the label placed right under the main label of the product and one diagonally from it. Really, there was no hesitation here in this study that eye tracking was the right method to answer this question, the noticeability question. Yes, we could have asked people about that, but that's just not as reliable of a method in this case. As humans, we're not fully conscious of where we're placing our attention at all times. Now, a little disclaimer about this picture. We obviously didn't analyze these heat maps. We analyzed the quantitative data, we crunched some numbers, did some statistics, but we illustrated our data with these heat maps. So that's why you're seeing heat maps here. If the answer to the second question is yes, because let's say eye tracking is the simplest or the only method to answer one of your research questions, then you can go ahead and add eye tracking to your study. There's no reason to ask the third question because you only need one yes, either a yes to question number 2 or question number 3. But if your answer to the second question is no, so let's say that you're early in the design process and just looking for usability problems, the low-hanging fruit, there's one more question to ask. And the third and last question in this decision tree is, does my study need a buy-in boost? Now, this should resonate with many UX researchers. And even though I said that people are not as excited about eye tracking anymore as they were maybe a few years ago, I feel that eye tracking studies still tend to get more attention in organizations than non-eye tracking studies. And this is especially true when eye tracking is new to the organization. I see more stakeholders coming to observe testing, more of them read the report, more attend the final presentation. And this is really not surprising. Eye tracking often serves as a marketing tool for usability testing. It definitely increases the visibility of research in organizations. You know your research stakeholders. These people come with different backgrounds. They have different levels of research awareness. Some believe that there's a problem with the design after they see, the first 2 participants in the study struggle. They want to make a decision. They want to make a change. Now others, they request higher sample sizes. They want hard data before they're comfortable with making any decisions or changes. Now, showing a gaze plot or a gaze video of a participant experiencing the problem that you just described suddenly makes that problem really hard to ignore. Now, in this particular example, the participant in the gaze plot took a long time to find the store locator link on this homepage. Showing a video of how he scanned the page for a while before noticing the top navigation really would help drive the point home. Now, that's also why we sometimes include participant quotes and video clips in reports and presentations. I'm sure you're familiar with those practices. And we do that to back up our findings, to illustrate them, to make our points stronger. Eye tracking somehow takes this evidence to the next level because eye movements are often seen as more objective than what people say or even do. But really, all this depends on the audience of your research. I have seen many very effective reports that didn't contain participant quotes, didn't contain video clips, and they wouldn't have probably benefited from eye tracking either. Now, if you already have your stakeholders' attention and buy-in, that's absolutely fantastic. But if you need that little boost, I would say go ahead and use eye tracking. If that's what it takes to convince people and make interfaces and products better, that's a small price to pay. But only do it as long as the first question is also a yes, and eye tracking makes sense for your study in the context of your research objectives. The book has a lot more examples and case studies, more detailed case studies related to when to use eye tracking and when not to. It also has 11 very beefy chapters on how to conduct a successful eye tracking study, from planning to analysis and reporting. And we have a few minutes for a couple of questions. I'm going to take a look at your questions now. If I don't get to yours, please don't worry. We can always continue this discussion on Twitter. Mike Whitston is asking, in your opinion, can webcams be effectively used to perform eye tracking? Well, that's a really good question. I actually couple years ago, I wrote a blog on this topic where I evaluated some services and I talked about it. And I think it's great that we're trying to go there. There are companies that offer, for those who don't know, there are companies that offer a webcam eye tracking services. So that means you don't need an eye tracker, and you can, as a participant, you can participate from your home, from pretty much anywhere, as long as you have a webcam. And then they gather data from a lot of people, because a lot of that data is not usable for many reasons. The frequency of the data collection is also varied because webcams really vary. So I'd say it's for a very rough picture. If you want to get a rough picture of something very, very simple, that could be a way to go. But the accuracy is not nearly as close to, at least from what I know, it's not nearly as, it's not comparable to actual infrared eye trackers that I showed you before. So we have accuracy issues. The sessions usually have to be really short because participants have to be in pretty still, and usually when people are on their laptop at home, there's a lot of things happening. So there are definitely some disadvantages to it, but I'm not disqualifying the method just yet. I think there's some reasons to do it. And I can push the URL. After this, I can tweet it, and I can tweet the URL to the blog post where I evaluated those services. Oh, Greg Pabst would like to know: are mouse movements or mouse move heat maps, like the ones provided by Clicktail or MouseFlow, a good alternative for eye tracking? That's another very good question. Well, based on research, there is a correlation between where we're looking and where we're clicking, but that correlation is small. It's a pretty low correlation. So if you really want to approximate how people look, and I'm not evaluating these particular services, but overall as a method, if you'd like to know where people look, a mouse move heat map, I would not use it as an approximation personally. And you can even think about it from your own perspective. When you are using a website, are you really moving your mouse over everything that you're looking at and reading? If something grabs your attention, I mean, our eyes move so much faster than our hand. Even if we wanted to move our mouse where we're looking, we even couldn't do that. But we simply don't do it. And the reason why there is a correlation between mouse movements and eye movement, that's when we are clicking on something. That's when the mouse and the eyes are at the same point at the same time. So that correlation mainly comes from that. And let's see if we have another question. Now, there are a lot of questions, and we might not get to all of them. Which eye tracker and analytics tool do you recommend? Marek Mrozicki is asking. I have tried a few different eye trackers over the past few years, and I have used the SMI eye trackers, the Tobii eye trackers, ASL, and other companies as well. They do have their advantages and disadvantages. It's pretty much anything. What I'd rather recommend is, I don't want to recommend a particular product, especially that eye trackers, and the software, these things are improving pretty much every month. There's another release of something, and these tools are just improving so very fast. So what I'd rather do is recommend some ways in which you can do research for what is best for you. So first of all, you need to figure out what kind of study it is that you're conducting, or what kind of studies do you conduct. Is what you're working on a website or something that you can show on the screen? And for that reason, you would need an eye tracker that's what we call a remote eye tracker, and that means that it's basically not sitting on the person. It's away from the person's head, usually under the monitor, placed under the monitor. So For those studies, that eye tracker would be the most appropriate eye tracker. Now, if you're doing something where people need to interact with things, with products, perhaps walk around environments such as an airport or a store, in that case you will need a wearable eye tracker. So then you're already narrowing down the type of eye tracker that you need, and then you only need to do research on those particular types of eye trackers. Then you want to look at things like, there are a lot of specs, and I feel like specs don't matter as much anymore because there are only a few eye tracking manufacturers, and each of them has a pretty short menu of eye trackers, and they're quite comparable at this point. I feel like they're quite comparable, especially for UX needs, for academic needs, when they need them to be they need more specific things. But for us, I would not be as focused on the specs of the eye tracker, the technical specs. I'd much rather want to talk to the people that are using the eye tracker and get their take on it. A lot of times what we really want for our practical use is this easy to use? Can I figure this out? Is the analysis robust? So you want to play with an eye tracker before you decide which one you want. There's all these companies, eye tracking manufacturers will be happy to demo their eye trackers for you. If you're at a conference, you can sit down at their booth. For my first study, I'd definitely not just purchase an eye tracker. I'd probably rent one. If I haven't had an eye tracker before, I'd probably rent it for a study and see how it's working out for me and then make that decision. I hope that answers your question somewhat. And I'll take one more question. Stefan Octavian is asking, given that there are 100 eye tracking features, and I'm assuming you mean measures, so given that there are 100 eye tracking measures, how do you decide on which you need for quantitative research? Are there some rules to follow or a table? Yes. So that's exactly what I showed you on slide. Let me display it right there. So on slide 62 that it should be displaying right now, what I did with all those measures is I figured out which measures are most practical for us, for UX researchers, and for evaluating interfaces. And I took all those. I left all the measures that are, let's say, saccade velocity. They're so specific, and they're used mostly in academic research. And there are resources that describe them in a really sort of detailed manner if you're interested. But I just took the ones that were most useful for us, not very complicated to get. So most eye tracking software applications are going to push these measures to you. You don't have to go into the raw data and try to figure out how to get them. So within these measures, so this is your table, and whatever you're trying to do, you can then decide from this table, are you looking at performance? Are you looking at attraction sort of types of questions? And then from there you can figure out what the cognitive process is that you're trying to measure, and then figure out which measures you'd like to use. And the whole chapter 7 in the book describes this in a lot of detail. So thank you so much for all your questions. I didn't answer a few, but please feel free to tweet them to me, and I'll be very happy to continue this.